Imagine standing 5 feet behind the roaring afterburner of a fighter jet taking off at full military thrust. The sound is not merely loud, it is a violent, kinetic punch that rattles your ribs, vibrates the enamel on your teeth, and leaves your lungs struggling to draw breath. Now imagine that exact same concussive blast detonating every 4 to 5 seconds, 8 to 12 hours a day, 5 days a week, inside an enclosed industrial cavern built of concrete, grease, and iron. Welcome to the floor of a heavy industrial drop forge. In this unforgiving environment, massive counterblow rams and pneumatic hammers weighing up to 50 tons crash down onto glowing billets of white-hot alloy steel at over 2200 degrees Fahrenheit. Every single catastrophic collision creates an explosive impact shockwave registering upwards of 130 to 135 decibels. In standard acoustic physics, continuous exposure to sound levels above 85 decibels guarantees permanent hearing loss over time. At 130 decibels, the threshold of human physical pain is breached instantly, and delicate sensory hair cells in the inner ear are obliterated in seconds. Yet, if you walk through the thick haze of burning graphite and glowing scale in legacy forge facilities across the industrial world, you will find master forgemen who have spent 30 or 40 years operating these monstrous machines. Many of them can still hear a normal conversation in a quiet room at the end of their shift. It sounds like an impossible biological contradiction. How does the human auditory system survive an acoustic war zone capable of cracking concrete foundations and shattering reinforced glass without succumbing to total deafness? If you are enjoying our channel, subscribe and turn on the little bell so you don't miss any content. It helps us a lot, and it's free. To understand how these workers protect their ears from total destruction, you first have to uncover a dangerous misconception about how sound actually destroys human tissue. Most people believe that hearing is purely an airborne phenomenon. A noise is generated, air molecules compress, sound waves travel down the ear canal, strike the eardrum, vibrate 3 tiny bones, and stimulate the microscopic hair cells inside the fluid-filled cochlea. Under that assumption, common sense dictates that blocking the ear canal with a standard foam plug or a pair of plastic muffs should solve the problem. Inside a heavy forge shop, that basic assumption is a fatal error. A massive drop hammer does not produce ordinary acoustic noise. It generates high-energy ballistic shock waves with peak acoustic pressure spikes that bypass the ear canal entirely through a hidden mechanism known as bone conduction. When tens of tons of hardened steel slam into an anvil block at high velocity, a massive surge of kinetic energy shoots directly into the earth. That mechanical shockwave travels across the factory floor, penetrates the heavy rubber soles of the operator's boots, and shoots up through the tibia, the femur, and the spine. The energy travels straight into the temporal bones of the skull. The cranial bones begin to vibrate at intense frequencies, agitating the fluid inside the inner ear directly from within. Even if you completely sealed your ear canals with solid lead, the impact would still attack your auditory nerve from the inside out, using your own skeleton as an acoustic conductor. This invisible skeletal assault is why standard safety protocols fail when machines reach this scale. To survive, forge veterans had to develop a layered defense system combining specialized dual barrier protection with counterintuitive biomechanical stances. But that was only the beginning of the puzzle. Because surviving the sound is only half the battle when you are also forced to operate lethal machinery without being able to hear a single word around you, and the way these crews communicate in absolute sonic chaos reveals a secret world of industrial survival. To block out an atmospheric assault of 130 decibels, the standard issue foam plug is practically a joke. The true defense begins with a meticulous ritual. Before stepping onto the floor, a drop forge worker employs a specialized dual barrier system. They roll dense, high-attenuation expanding polymer plugs tightly, inserting them so deeply into the ear canal that they nearly touch the tympanic membrane. Once the foam expands to create an airtight seal from the inside, they clamp down heavy-duty, military-grade earmuffs over the top. This outer shell is not just plastic. It is lined with dense acoustic foam and liquid-filled cushions designed to break the physical wave of sound before it even reaches the skull's surface. But as we just uncovered, blocking the air is only shutting the front door, while the back door is wide open. The real danger is the ground beneath their feet. This is where human biomechanics become the ultimate survival tool. If you watch a veteran forgeman operate a massive steam hammer, you will notice something peculiar about how they stand. They never lock their knees. They stand with a slight, permanent flex in their legs, turning their own muscles and tendons into biological shock absorbers. More importantly, they never clench their jaws. When that 50-ton ram strikes the anvil, the shock wave violently shakes the concrete. If a worker has their teeth clamped shut, that seismic energy travels straight up their legs, up the spine, through the rigid jawbone, and directly into the delicate structures of the inner ear. By keeping the mouth slightly open, or resting the jaw loosely, they physically disconnect the bone conduction pathway. They are literally hacking their own skeletal structure to prevent the noise from rattling their hearing to death from the inside out. Yet, this impenetrable auditory defense creates a terrifying new problem. You are now artificially deaf in one of the most dangerous environments on Earth. You are surrounded by blindingly bright steel heated to over 2,000 degrees, swinging tongs, massive cranes, and a hammer that can crush a truck engine into a pancake in a fraction of a second. The margin for error is absolutely zero. Would you trust your life entirely to the subtle vibrations beneath your boots and the fleeting eye contact of your crew under these extreme conditions? Let me know in the comments below, because the way these crews adapt to this sensory deprivation is nothing short of incredible. And one mistake in this silent environment means an instant catastrophic disaster. Deprived of voice and hearing, the Forge crew develops a crude, highly effective nonverbal language. It is an industrial ballet choreographed in extreme heat and crushing pressure. They do not need to hear the machine to know what it is doing. They feel it. A veteran can tell if the steel is at the correct forging temperature simply by the specific frequency of the vibration traveling through the soles of their boots. A sharp, stinging vibration means the metal is too cold, and the die might crack. A dull, heavy thud means it is ready to be shaped. They communicate through sharp nods, exaggerated hand signals, and intense, unbroken eye contact. The hammer operator and the tongs man move in perfect, terrifying synchronization, anticipating each other's actions through muscle tension and breathing patterns. They become an extension of the machine, reading the physical environment through their skin and bones rather than their ears. This hyper-awareness keeps them alive, and the dual protection system combined with bone conduction awareness saves their eardrums. But survival in the heavy forge is never without attacks. While they may walk out of the factory with their hearing intact, the machine always demands a toll. Protecting the ears is one thing, but what happens to the rest of the human body when it is subjected to a daily diet of skeletal shockwaves and extreme thermal stress? The long-term physical cost of this silent survival is something the industry rarely talks about, and the reality of what this job does to a human skeleton over 20 years is deeply unsettling. The reality is that you cannot cheat physics, you can only redirect the damage. By altering their posture to protect their auditory nerves, drop forge operators intentionally force their skeletal system to absorb the kinetic punishment. Over a career spanning 2 or 3 decades, the human body attempts to adapt to this extreme environment, but it does so at a severe, irreversible cost. The continuous micro-trauma of absorbing 50-ton shockwaves fundamentally alters the density of their leg bones. Many veteran workers develop a severe degradation of the cartilage in their knees, hips, and lower lumbar spine. They are essentially trading their joint health for their hearing. It is a dark, calculated sacrifice made on the factory floor every single day. They might walk away at retirement with the ability to clearly hear their family speak, but they will likely carry a chronic, deep bone ache that no medication can fully erase. Yet, the physical toll is only the surface layer of this brutal reality. There is a psychological phenomenon that heavy forge operators rarely discuss with anyone outside of the heavy industrial brotherhood. It is a lingering phantom sensation, a neurological ghost born from thousands of hours of intense, rhythmic sensory conditioning. Long after the shift ends, long after they have scrubbed the black graphite grease from their hands and returned to the quiet safety of their homes, they can still feel the drop hammer. As they lie down to sleep, their muscles will frequently and involuntarily twitch, perfectly in rhythm with a machine that is miles away. Their brains have been so deeply rewired by the environment that they anticipate a massive seismic impact every 5 seconds. For these veterans, the absolute peaceful silence of a normal room can actually become maddening, triggering a restless anxiety for a physical shockwave that never arrives. They have synchronized their central nervous system with an iron beast, and disconnecting from that rhythm is a slow, agonizing process. This extreme, unforgiving environment creates a breed of worker bound together by an unspoken reliance on one another. The modern world is completely detached from the violent, dirty genesis of its own conveniences. Every time you rely on the heavy-duty suspension of a truck, every time you trust a high-tensile wrench to not shatter under immense pressure, or fly in a commercial aircraft secured by heat-treated structural fasteners, You are putting your life in the hands of steel that was violently beaten into submission. And behind every single one of those flawless, indestructible metal components is a human being who stood in a localized earthquake, vibrating down to their very marrow, communicating only through eye contact, and quietly trading pieces of their own physical foundation to ensure the metal holds strong. The Drop Forge does not just compress glowing iron, it compresses human energy, resilience, and endurance into a hardened, finished product. The next time you hold a piece of industrial forged steel, do not just casually look at the polished surface or admire the engineering tolerances. Feel the heavy, dense weight of it in your hands. Understand that to bring that simple object into existence, someone had to willingly step into an acoustic hellscape, seal themselves off from the auditory world, and allow the earth to violently shake them to their absolute core. They are the silent, unseen architects of the modern industrial age, paying a daily, irreversible price in bone and cartilage, so the rest of us can live in a world that does not break. This is not just manual labor. It is a daily, lethal negotiation with physical forces that could vaporize a human being in a fraction of a second, mastered only by those who have learned exactly how to survive the silence.